Hello and welcome to this Python tutorial. So in the two previous tutorials we added three layers, the input layer, the first hidden layer and the second hidden layer, and now in this tutorial we're going to add the output layer. So again, it's going to be very easy because we only need to copy the previous line here and paste it here and now change a few things. So try to guess what we are going to change. It's pretty straightforward. The first thing we need to change is, of course, the output dim parameter, because of course in our output layer we want only one node, because our dependent variable is a categorical variable with a binary outcome, 0 if the customer stays in a bank and 1 if the customer leaves the bank. And when we have a binary outcome, there is only one node in the output layer, and therefore here we need to input output dim equals 1. So good. Then we will keep this uniform initialization method that is still used to initialize the weights that comes from the second hidden layer. But moving on to the third argument, well, if you remember what I said in the previous tutorials, we need to change the activation function here. Because right now we are in the output layer, and since we are making a geodemographic segmentation model, we want to have probabilities for the outcome, because we want to have the probability that each customer leaves the bank. And so in order to get these probabilities, we need to replace this activation function, which is the rectifier activation function, by the sigmoid activation function. Because remember in the logistic regression intuition tutorial given by Kirill in part 3, well, this sigmoid function is the heart of this probabilistic approach, and that is thanks to the sigmoid function that we managed to get some probabilities in the logistic regression model. And that will actually be the same here if we choose a sigmoid activation function. It's the exact same principle. So here we're going to replace ReLU corresponding to the rectifier function by sigmoid. And by the way, if you are dealing with a dependent variable that has more than two categories, like say for example 3 categories, then you will need to change two things here. First is the output dim parameter that will be set as the number of classes, because it will be based on the one-VSL method, while the dependent variable is one-hot encoded. So here you will need to input 3 if you have 3 categories for your dependent variable. And the second thing that you will need to change is the activation function, that in this situation would be softmax. And softmax is actually the sigmoid function, but applied to a dependent variable that has more than 2 categories. So just keep that in mind if in your work you are dealing with a dependent variable that has more than 2 categories. Like 3 or 4 categories, you will need to choose the softmax function. But here we have 2 categories, 2 classes, so we are fine with the sigmoid function, exactly like for logistic regression. Alright, so basically we are ready. We are ready to add the output layer that is eventually the final layer of our neural network. That's pretty exciting. That means that we are done building the neural network. Well, then we'll need to compile it, but basically we're done adding all the different layers. So let's do it. Let's add the final layer, the output layer. And so I'm going to select this line and press Command or Control plus Enter to execute. Here we go. The output layer was successfully added. Great, so now we are ready to move on to the next step, which will be to compile our artificial neural network. That's going to be very easy as well, since it will only take 1 line of code. And so we'll do that in the next tutorial. Until then, enjoy machine learning.